In these problems, 3 through 6, it gives us several instructions. The first thing they want us to do is to graph the quadratic function. Then they want us to label several things: the vertex, the axis of symmetry, and the x-intercepts, and then they want us to describe the domain and range. So we know that in this lesson, we're using the x-intercepts to graph. So we're going to start out looking at number 3 and trying to find the x-intercepts. To find the x-intercepts, we want to factor it. But what do you notice about number 3? It's already factored. So all we want to know is what values of x are going to make it equal 0. So what value of x makes this first part equal to 0?
-3.
-3.
And 1.
And then what makes the second one 0? Right, and 1. So those are our x-intercepts. We can plot those. How much work did we have to do? Not a lot. So we already know that that's right there. Can we tell by looking at our x-intercepts where our axis of symmetry is?
Yes, we can.
Okay, where do you want me to move this to?
-1.
Here?
-1.5.
How far is it this way?
I actually think it looks right.
Yeah,
And
that's
2?
right.
So there's a distance of 4 in between, so 2 puts us right in the middle. So now we know, and I would go ahead and write that down. That's x equals, and what is that? It's over 1 from 0, so -1. That's our axis of symmetry. Now we're going to take this equation to find y. We're going to plug in a -1 for x.
2.
So -1 plus 3 is, and -1 minus 1 is, so we get the same thing actually as we did on the last problem we were doing earlier. So -1, -4 is our vertex. So -1, you can't see quite down that far. 1, 2, 3, 4. We do want to notice what is the shape of this one. Is there a stretch or a shrink to this?
It's
What do you see right here?
oh, there's nothing.
So that's a 1, right?
Yeah.
So it's the same shape as the parent function.
So it's
So
neither.
right, so it's neither. So we're going to go over 1 and up 1, just to give us a couple points to better graph it. Over 2 and up 4, it puts us right there at those points we already plotted.
We'll always do that.
And so that's where we are.
That is
So we need to identify all the parts that they asked for. The vertex, we're going to identify down here as -1, -4. Our x-intercepts, this one is -3, 0, and 1, 0. We already labeled our axis of symmetry at x equals -1. And so the last thing we need to talk about is the domain and range. What is the domain for this function?
all real numbers.
All real numbers. We know for quadratics, we can use all real numbers unless we're talking about a word problem, and then we need to be careful. What about the range? What do we notice about the y values?
Y is greater than or equal to
Y is greater than or equal to -4. Our lowest point is down here where y is -4. Everything else is above that. So there's our domain and our range for this function. All right, any questions about that one? Okay, I'd like to talk about one more of these. Let's get rid of the work we've done for this one. And let's talk about something like number 5. Is number 5 already factored for us? No. So we have to look and say, what do 2x squared and 16x have in common? What can I take out of both of those? 2 and x, which is going to leave me with x minus 8. So when I want to know what makes it equal 0, 2 times what gives me 0?
2 times 0.
2 times 0 is 0, so 0 is one of my x-intercepts. And what minus 8 gives me 0? 8. So we're at 0 and 8 for our x-intercepts. So where do I need to move my axis of symmetry? 4. Because 4 should be right in the middle, right? Now how do I find where on that line my vertex goes? So that's where my line is, but where on the line, what do I do with that x equals 4 information?
Plug it in.
I plug it in. So what is 2 times 4? 8. And 4 minus 8 is, so 8 times negative 4 is negative 32. Does that fit on this graph that I have drawn here? What if we scale it? And we could say 2's might not get us there, but 4's definitely would. So let's say this is negative 4, so that would be negative 8, negative 12, negative 16, negative 20, 24, negative 28. Woo! We need to go way far down, don't we? That's an 8. 28. So this would be 32. So it would be all the way down here. All right. Does this have a stretch or shrink? What was our leading coefficient up there?
2, so
2.
it's a stretch.
It's a vertical stretch by a factor of 2. And so we would look into that. We could keep going. Okay, let's look at the other things we're going to be asked to do. Find the zeros of the function. And what are the zeros the same as? The x-intercepts. So when it asks for the zeros, they want the same thing as the x-intercepts. What makes this equal 0?
Oh, so we
5. And what makes this one equal 0?
9.
9. That's it. Those are the zeros.
Oh, I thought that was a little harder.
Okay, what about on 9? Is it going to be as easy?
No, it's not.
We have to factor it. So we need factors of negative 30 that add to give us what?
I have to give a 7. I have that.
But negative 7? So what do I need to do with my signs here?
Switch them.
Switch them. So it's going to be x plus 3 and x minus 10. So what makes that equal to 0?
Oh, so -3 and 10.
Negative 3 and positive 10. So you're doing the same thing. If they ask you for the zeros or they ask you for the intercepts, you're doing the same process. One has to do with an algebraic answer, so the algebra of it. One of them has to do with where it is on the graph. So that's why they have 2 different names. This says use the zeros to graph the function. Isn't that what we were doing a minute ago?
Yes.
Yes, that's the very same skill. What are the zeros for this problem?
-1 and 3.
Negative 1 and positive 3. So we would graph negative 1 and positive 3. There's our axis of symmetry at x equals what?
-1.
1. So what's 1 plus 1?
2.
And what's 1 minus 3?
-2.
So 2 times negative 2, negative 4. Good grief, I feel like we've seen that same vertex so many times. Here. All right. That gives us an idea of the graph. If it's not factored, like this one, you're going to need to factor it. X minus 3, x plus 2, and that'll give you your zeros, 3 and negative 2, and you can plot those. They might not all be nice numbers when you have the axis of symmetry. It might be 1.5 or something. That's fine. You're going to see that. That's okay. Okay, another thing they're going to ask you to do is to be able to write a quadratic function. They want it in standard form. That's this one, ax squared plus bx plus c, that satisfies these conditions. Now, they're just asking for a quadratic function. They're not asking for a specific one because there are several equations you can write using these qualifications. They just want you to write one of the possibilities. If we know the vertex is at -5, 4, we probably want to start with vertex form. Y equals a, x minus h squared plus k. Remember the vertex is h and k. That's what we were practicing last time, was plugging in those values. Y equals, they're not giving me an a, so I'm going to pick 1. X minus h, so that's x plus 5 squared plus k plus 4. That's just one equation. I could put any number I wanted in that spot right there because they didn't give me exactly what they wanted. Now, is that in standard form? That's not standard form.
No, that's an intercept one.
That's vertex form. Oh, that was vertex form. So to get this into standard form, which is this one, I have to take this x plus 5 squared plus 4, and what do I need to not have?
The C.
Well,
The parentheses.
the parentheses. So I need to do x plus 5 times x plus 5. And then once I've done that, I can add on the 4. So we did that when we FOILed. X times x is x squared plus 5x plus 5x plus 25 plus 4. And if we just combine the like terms, what's 5x plus 5x? 10x. And 25 plus 4?
29.
Perfect. So that's the equation in standard form. Cool. All right.
Wheels first, outside.
Yeah, so when we're foiling, we do first times first, outside times outside, inside times inside, and last times last. Okay, let's clear this. And let's look at 16. 16 says they want you to write another equation, but this time they gave you the intercepts. So if the intercepts are at 2 and 7, and that's what intercept form looks like, y equals a, x minus p, and x minus q. P and q, those are our x-intercepts, right? That's where it hits the axis. I'm going to choose 1 for my a to make it easier. So I'm going to do x minus 2 times x minus 7. Wouldn't that give us positive 2 and positive 7 for our x-intercepts? And then they want you to multiply it together so that it's in standard form. Y equals x times x is x squared. X times negative 7 is negative 7x. Negative 2x, positive 14. And then our last step is just to combine like terms. X squared minus 9x plus 14. Okay, so they can ask you a variety of different ways, and those can be very different problems. This one, you'll notice they gave you the x-intercepts, but they didn't tell you. Do you know how I know those are the x-intercepts?
Because you 0.
Their y's are 0, which means they haven't moved up or down off the graph. All right, so
Does that mean that on number 17, the 0, negative 3, and 1 are also the x-intercepts?
perfect. Now, since this one they gave you another ordered pair, that's going to ask for a more specific equation.
Okay.
All right, that's the end of that.